Finding missing numbers looks like it needs extra storage, but there's an in-place marking trick. You are given an array of length n where each element is an integer between 1 and n inclusive. Some numbers may appear twice and others not at all. Your job is to return a list of all the numbers from 1 to n that do not appear in the array. For example, with the input 4, 3, 2, 7, 8, 2, 3, 1, the missing numbers are 5 and 6. The straightforward way is to record every value you see in a hash set, then scan from 1 to n and collect the ones not in the set. That runs in linear time but requires linear extra space for the set, which is often frowned upon in interviews because we can do better. The key insight is that the values themselves are valid indices, so we can use the sign of each array element as a visited flag. We iterate through the array, take the absolute value of the current number, subtract 1 to get an index, and if the element at that index is positive, we flip it to negative. After the first pass, any position that remains positive corresponds to a number that never appeared. A second pass collects those indices plus 1 as the missing numbers. You'll recognize this pattern when you have an array of size n containing values from 1 to n, and you need to track presence without extra space. Time complexity is big O of n because we scan the array twice. Space complexity is big O of 1, constant time extra space, not counting the output list. Try the next problem, same pattern. Subscribe for more in-place array tricks.